but our presenter today is Mr. Justin Hendricks, who is our Technical Manager of Openings out of our Middleton, Wisconsin lab. And he is going to present on the importance of field inspection and labeling. So with that said, I'll go ahead and pass it over to you, Justin.
Thank you. Hi, everyone. Welcome to the importance of field inspection and labeling. Here's the agenda for today. I'm going to go through a few background items first, then transition into process and tools, followed by NFPA 80 requirements, some field examples, and then finish up with some additional resources. My name is Justin Hendricks. I'm the technical manager of the openings group at Intertech. I've been with Intertech for over 13 years now, with my primary focus being fire doors. Gone through testing, certification, field inspection. Currently, I manage and oversee the field inspection services group, but I'm still heavily involved with reviewing fire door evaluations and listings and things like that as well. So let's start out with some background information, the importance of field inspection and labeling. Why are field inspections and annual inspections needed? So if we look at some of the statistics between 2010 and 2014, NFPA statistics show an average annual 498,400 commercial structural fires in the United States. Within these statistics, fire sprinklers were present in only about 10% of those fires. So you have almost 450,000 fires during that period of time in non-sprinkler facilities. And in those cases, nearly 30% or 130,000 had the fire spread beyond the room of origin, resulting in substantial property loss and potentially the loss of life. So the big key here is that the failure to properly inspect and maintain fire door assemblies and other opening protectives, especially in non-sprinkler buildings, could result in jeopardizing the safety of building occupants, as well as substantial property damage and liability claims in the event of a fire. If we kind of open this up a little bit further and look at some of the importance of fire testing, certification, and labeling in general as a whole, we can look back at some historical examples as well, and I have three on the screen here. We have the Iroquois Theater fire, that was in Chicago, Illinois, quite some time ago, but still a lot we can learn from that. That was the deadliest single building fire in the United States. 602 people lost their lives. While there were a lot of factors that went along with that particular fire, if we look specifically at the doors, there were several doors that opened inward. So as people were trying to exit the building due to the fire, they were pushing against the door and pushing the door against the door, the frame stop. So it hindered people from adequately exiting the building. Next, we have the Triangle Shirtwaist Factory fire. This was in New York City. Again, a lot of different factors with this one, but if we look at the doors specifically, many of the stairway doors were locked, preventing people from escaping. There was an exterior fire escape that ended up collapsing. So again, door-related items, preventable items. And last but not least, we have the Beverly Hills Supper Club fire. Like the other two, a lot of issues with this one, with the building itself. But if we look at the door specifically, a majority of the paths of egress in each room did not lead to the outside, but actually led to a narrow interior corridor and different service spaces. So it was almost like a maze for people to try to get out, obviously, leading to loss of life and substantial property damage. So with all of these, there's lessons to be learned, and with these fires and disasters, it did lead to code changes and standard changes in regard to fire doors and other opening protectives. So if you're interested in history, I would recommend taking a look at each of these. Last but not least, if we kind of narrow the focus down to field inspection and field labeling in general, what are the implications to end users? If something is labeled wrong, what are the consequences? First and foremost would be risk and liability, loss of life, loss of property. That's the most important thing to keep in mind here. Secondary to that would be any industry and community reputation for the building owner, the facility manager, general contractor, etc. At the end of the day, we're not just showing up and applying a label to a door or frame. There's more that goes into it than that. We're trying to tie back an assembly that we potentially label to something that we have historical information on, test data, listing. And on top of that, we're also looking for non-conformances with the door assembly itself that should either be corrected or lead to replacement of components. With that, we're going to segue into fire door standards and testing. Just wanted to give a brief overview here. We're not going to spend too much time on this topic, but I think it's important for people to at least have a basic understanding of what these products go through from a testing perspective, to understand, why we take these things so seriously when we're field inspecting. If you're interested in diving a little bit deeper into fire door standards and testing, we do have other webinars, a Fire Door 101 webinar that goes into this information in a little greater detail. Here are the 4 primary fire door standards in North America. We have UL10C, which is for side hinge swinging doors. It's a positive pressure test standard. If you're not familiar with positive pressure and neutral pressure, we'll get into that in a slide here. And then we have 3 other standards that cover multiple door types. This could be certain side hinge swing door applications, but other applications such as elevator doors, chute doors, access doors, and things like that. So we have UL10B, which is neutral pressure, NFPA 252, which can be conducted under positive or neutral pressure. And finally, the Canadian standard CAN-ULC S104, which is a neutral pressure standard. The IBC, or International Building Code, which is the model building code of the United States, references UL10B, UL10C, and NFPA 252, whereas the NBC, the National Building Code of Canada, references CAN-ULC S104. Here's the time temperature curve. So these are the temperatures within the furnace. So for a fire test, we would actually mount a door in a door frame with hardware, so the door is operable at the start of the test. That would be mounted in a test wall and then fixed to the furnace. So this chart only goes to 90 minutes, but we do conduct tests up to 3 and 4 hours. But the key here is to see what types of temperatures these doors and frames and hardware are being exposed to. You can see very early on, we're at 1,000 degrees Fahrenheit 5 minutes into the test. And then shortly after that, at 20 minutes, we're at 1,462 degrees Fahrenheit. So the temperature within the furnace ramps up very quickly, exposing the door and frame assembly to very high temperatures. So combustible, consumable components, those could start to degrade, melt very, very quickly. And then the temperature gradually ramps up from there. So we looked at neutral and positive pressure a little bit when we took a look at the 4 primary fire door standards in North America. So what that actually means is in regard to the furnace pressure. So if we take a look at UL10B as an example first, it's a neutral pressure test standard. So what that means is that the pressure plane within the furnace, the neutral pressure plane, is established at the top of the assembly. So everything below that will be under negative pressure. So ambient air, which is cooler, will be drawn into the furnace around the door and frame interface and any other possible hardware cutouts and things like that. So essentially what's happening is there's a cooling effect happening around the perimeter of the door. So the edges will be a little bit more protected. If we look at a positive pressure scenario using UL10C as an example, on the right-hand side of this diagram, we can see that the neutral pressure plane is established 40 inches above the sill in that case. So again, anything below the neutral pressure plane will be under negative pressure. You'll be drawing in ambient air. It will be providing a cooling effect in that area of the door and frame interface. Anything above the neutral pressure plane will be under positive pressure. So essentially what's happening is the hot furnace gases are being forced through the door and frame interface or any other hardware cutout, leading to potential degradation, especially if we're dealing with wood or wood composite products, or other types of composite or metallic products that have a lower melting point. So with a positive pressure scenario, you could see advanced degradation, specifically between the door and the frame interface, that you may not see in a neutral pressure application. Following the fire endurance test, there's a hose stream test. So the exposed or fire side of the test sample is impacted and exposed to the cooling and erosion effects of a hose stream. This isn't your typical garden hose, it's an actual fire hose, as you can see from the photo on the right-hand side. So there is a decent amount of impact and erosion forces that the door assembly will be experiencing during this portion of the test. For 20 to 120 minute fire endurance ratings, the pressure will be 30 psi, and then that bumps up to 45 psi for anything 3 hours or above. There is a duration multiplier, which is dependent on the fire endurance rating. So for instance, 20-minute fire endurance rating would have a duration multiplier of 0.6 seconds per square foot, whereas a 60-minute fire endurance rating would have a duration multiplier of 1 second per square foot. There is a 20-minute without hose stream rating that is recognized in the United States and parts of Mexico, and that is in the IBC. We'll touch on that in a couple slides here. So speaking in regard to positive pressure and edge construction, many door assemblies, especially those with consumable or combustible materials on the edge, utilize intumescent materials to help protect against the effects of positive pressure. Intumescent materials are materials that expand under heat. Essentially, their job is to fill a gap. Their activation temperature is typically from 250 degrees to 450 degrees Fahrenheit, but it depends on the type of intumescent material. So we have a couple scenarios shown here below. On the left-hand side, maybe a little bit difficult to see, but this would be a category A door, wood door with a concealed edge seal. So that there's a little black line just slightly in from the edge adjacent to the door frame. That's representative of concealed intumescent. So as the door is exposed to fire, eventually that intumescent material will react and it will work to fill the void between the door and the door frame, essentially limiting the effects of positive pressure. On the right-hand side, we see a category B wood door that, in this case, has a surface-applied category G edge seal system. So in this case, we have a gasket applied to the frame. That's a category G seal. It could be an intumescent material that, again, once it hits activation temperature, its job is the same. It's to fill that gap there and reduce the effect of positive pressure degrading that interface. Here are the sections within the IBC. This is the most recent version of the IBC for reference 2021, but the same language is in the previous iterations as well. So if we look at section 716.2.1.1, side hinged or pivoted swing doors, these door assemblies are required to be tested in accordance with NFPA 252 or UL 10C under positive pressure furnace conditions. If we look at section 716.5.2, these are for other types of assemblies. It could be swinging elevator doors, horizontal sliding fire door assemblies, rolling steel doors, fire shutters, chute doors, access doors. Those are required to be tested in accordance with NFPA 252 or UL 10B to neutral pressure. So that's where those requirements come from. And last but not least, we touched a little bit on the 20-minute without hose stream allowance. So that actually comes from section 716.2.2.1 of the IBC. And it's for door assemblies and corridors and smoke barriers. So there is an exemption there as shown on the screen here for the 20-minute without hose stream rating for those applications. Door assemblies and other fire partitions are required to meet a minimum fire protection rating of 20 minutes. And those have to pass the hose stream test as indicated by section 716.2.2.2 shown on the screen. There is a reference here on this slide to table 716.1 subsection 2. That's a great resource if you're looking to match up a wall assembly type, what the wall rating is, where it's located, to a fire door assembly rating that's needed for that application, glazing allowances, things like that. Again, that's found in the IBC. It is available online for free, so I strongly recommend taking a look at that if you're interested in seeing what fire door ratings, assembly ratings need to match up with the different wall types and wall assembly ratings. All right, from there we're going to move into the process and tools. So what is field labeling in a nutshell? If your already installed fire doors and door frames are missing a proper certification mark, a listing agency's field labeling services such as Intertech may be able to help avoid removal and replacement of unlabeled openings. So field labeling might become necessary for a variety of reasons. This could be field modification done to the door or the frame, doors leaving factories without labels. Maybe they forgot to put the labels on and they arrived at the job site without labels. Incorrect labeling, perhaps they were labeled with too high of a rating or something similar to that, or labels that have been painted over or removed. That last item there, the painted over labels or removed labels, that would take up a majority of the requests that we see. Following in a close second would likely be doors or frames that have been modified in the field. So for field labeling, what do? We conduct a comprehensive review of all components in question. Even if we're there just to inspect and label the door leaf, we're also going to take a look at the frame that door is mounted in. We'll also take a look at the hardware and just make sure that there aren't any other nonconformities that need to be addressed. So while we may be able to label the door if the door complies, there may be other secondary items that need to be fixed, repaired, addressed, etc., and may require additional inspection either by us, Intertech, or the authority having jurisdiction. We'll provide you with a written deficiencies report with what we find. We'll offer support for modifications and corrections. So if we do find nonconformances, we can help you navigate how to fix those issues. Again, some issues may not be able to be fixed. They may require replacement, but those that can be fixed, we can offer some support there. We can provide reinspection services as needed. And then finally, we would apply the Intertech fire rating label when appropriate and applicable. I have the website for our field labeling program on this slide. Recommend taking a look at that. In addition to the door and frame field labeling that we're talking about today, we also have an electrical division that does field inspections for electrical components. So how do we determine compliance? As the listing agency, we have access to manufacturing and machining procedures as well as historical test data for opening protectives. This is for current clients as well as past clients spanning decades. So we have records of old assemblies as well. We use this information as well as the information that we gather during our field inspection to tie back what is in the field to something that we have information on. This information, the listings, the test reports are key in determining the compliance for the full door assembly. We do have directories, Spec Direct and our Intertech listing directory, that have publicly available information that can indicate what a door manufacturer, door frame manufacturer has the ability to produce. Those listing directories also have proprietary information specific to Intertech and our clients, but that information we can pull from as well to identify assemblies in the field. There are also industry standard construction guidelines that are also occasionally used to supplement the manufacturing and machining procedures as well as historical test data. These include UL Subject 63 and CAN UL CS 105 for certain hollow metal frame designs. There may be stamps, barcodes, or other markings on the door or the frame that also may help identify a manufacturer or distributor. However, these stamps will not necessarily identify what type of hardware can be installed in the door, the maximum door sizes, or other component allowances, as an example, cladding, face material, intumescent use, etc. So it's imperative that you have the full picture, and as a listing agency, we would have the ability to dive a little bit deeper. So if we can identify a door or frame as being from manufacturer ABC, we could also take a look at what other allowances they have to ensure that what's present in the field is representative of what we have or had certified, and what we have test data to back up. The listing agency stamp on the top of a door or barcode is not equal to a fire label. Oftentimes these stamps are further processing marks placed on the door or frame before finishing, so prior to doing machining and things like that. We also avoid drilling into a door or frame to check the material type. This can potentially affect the fire protection performance of the door or the frame. We try to be as less invasive as possible using visual methods. May require us to have hardware removed, a lock set or a hinge, just to try to verify material types. So when field labeling services are required, AHJs, authorities having jurisdiction, manufacturers, contractors, facility managers need to be assured that the body conducting the field inspection and labeling service has an in-depth knowledge of the doors and frames that they are labeling. We have staff members that have spent time in the lab. We have, as I mentioned before, access to listing procedures, test data, and things like that. And then finally, there are some instances where the safest path forward to bring in old opening protective assembly up to code is replacement. There's some instances where either we can't identify a sample in the field, or it may have been modified beyond the scope of what we have on file, or beyond the scope of what we can rationalize or retest, and those assemblies just need to be replaced. So from a field labeling perspective, what is needed to kind of get the ball rolling? Providing the listing agency with any information that you may have will help save valuable time in the field. This would include the job site address, number of affected openings, the door frame manufacturer, distributor, or supplier, if you know that, any identifiable markings on the door or the frame, any modifications that you may be aware of made to the affected openings, and then last but not least, any drawings or photos that you may have. All that information will help save time in the long run, so we can do a little bit of research before we actually get to the field. Last but not least, in regards to the modification aspect, per section 5.1.4 and 5.1.5 of NFPA 80, field modifications shall be addressed by the lab, which lists the product or component. So again, if you know of a product that has been field modified and perhaps it already has a label on it, contact the agency on that label, and then they can help address that field modification. So once we have all the information, the basic process is that the client will receive a quotation, sign it, arranges for prepayment, and returns it to Intertech. The Intertech office then notifies the appropriate Intertech field representative with the information that goes along with the project and any special instructions. As soon as the Intertech field representative receives the contract, he or she will contact the client to schedule the inspection. If we can't reach the client by phone, we'll send out other means to try to reach them. In regard to our inspections, we have rush inspections available that will generally be conducted within 5 business days or less of receipt of the proposal. And then our standard inspections will generally be conducted within 8 to 10 business days. If there's a specific timeline that you need to meet, just let us know and we will do our best to meet that. We do have personnel from coast to coast, so we have a strong network of inspectors to be able to perform this work. So while in the field, it's a good idea for the client or the client's representative to have a step ladder, some hand tools to remove locks, hinges, glazing, or other vision panels, and a skilled handyman that can do maybe minor rework at the job site, especially if we find things that are easily correctable that could be corrected while we're on site. That would also help with the process. The Intertech field representative does not do any rework themselves. They're there to inspect and relabel if applicable. The client or his agent must conduct any rework, removal, or replacement parts from the assembly. This is just to maintain proper third-party separation and avoid conflict of interest between what we're doing as field inspectors and the maintenance that's required on the door itself. Here's some typical field tools our field inspectors may bring with them. Not a complete list, but these are the most common. Tape measure, magnet, flashlight, door gap gauge, camera, telescoping mirror, proper PPE. If there are specific PPE requirements for your facility, please let us know that ahead of time and we can work to obtain those items. Same thing would be said for any security clearances needed. Last but not least, magnifying glass, and then calipers or micrometer. From there, we're going to segue into NFPA 80 requirements. For those of you not familiar with NFPA 80, it's the standard for fire doors and other opening protectives. It's a great document, great tool, goes into detail on ongoing maintenance requirements, inspection requirements, installation, labeling, all sorts of great information. In regard to field labeling, the current version of NFPA 80 2019 details that field labeling is to be performed by the listing agency that maintains periodic inspections of production of labeled equipment or materials under review and by whose labeling the manufacturer indicates compliance with appropriate standards. So it basically narrows it down to the listing agencies. If we look at older versions, 2013 and prior had no dedicated section to field labeling. Starting in 2016, there was a dedicated section for field labeling. This allowed individuals or companies that were certified or listed, could be non-listing agencies, to perform field inspection and field labeling. The upcoming version, the 2022 version of NFPA 80, will revert back to the 2016 version for the time being, again, allowing individuals or companies that were certified or listed to perform this work. So it's imperative to understand, who you're choosing to do the work, what their background is, and what information they may have to back up any rating that they're applying to a door or frame. Keeping along with NFPA 80, in Chapter 5, there's 13 points of inspection. This information is the same for the 2013, 2016, and 2019 versions. These are all great points to be aware of. We'll go through them in the next slide. But as I mentioned before, a door or frame might meet the necessary criteria for field labeling. However, as an assembly, there might be other issues that require additional correction and additional visits, either from us, the listing agency, or the authority having jurisdiction. So knowing these 13 points of inspection ahead of time will help reduce the need for follow-up visits and will save you time and money in the long run. As an example, many items that could be flagged during an inspection are easily correctable, such as open fastener holes. You see that a lot. Someone may have replaced a surface-mounted closer with another model of surface-mounted closer, and there's a couple fastener holes either left in the frame or the face of the door. There is a section within NFPA 80, section 5.5.7, which details repair methods for fastener holes. So again, being aware of this ahead of time may prevent reinspection or these items at least being flagged as non-compliant. Last but not least, getting in the habit of keeping and maintaining good records in regard to annual fire door inspections and maintenance are also very helpful. Again, documenting any modifications that are made, things like that. where doors are coming from as far as the supplier hardware. That's all helpful for us in the long run when we're field inspecting an assembly. So here are the 13 points from NFPA 80, Chapter 5. If you're not aware of these points, we can supply this document that you see here on the screen for you. If you're interested, just reach out to us. So just quickly going through the list here, we have door clearances do not exceed the clearances listed in NFPA 80. We'll go through those a little bit more in detail in the upcoming slides. The latching hardware needs to operate and secure the door when it's in the closed position. The door, frame, hinges, hardware, non-combustible threshold, all of those items need to be secured, aligned, and in working order with no visible signs of damage. No parts can be missing or broken. If there's signage affixed to the door, there are specific requirements for that as far as size and material type. Those are also detailed within NFPA 80. Labels need to be clearly visible and legible. Obviously, if we're there to field label, there's a good chance that that would not be the case. Label could be painted over or missing. But labels on all the other components need to be visible and legible. No open holes or breaks exist in the surfaces of either the door or the frame. Again, that's a very common one, going back to open fastener holes and things like that. The self-closing device needs to be operational so that the active door completely closes when operated from the full position. If a coordinator is installed, so this would be a pair of door application, the inactive leaf needs to close before the active leaf. Any meeting edge protection, gasketing, and edge seals where required are inspected to verify their presence and integrity. Any glazing, vision light frames, glazing beads need to be intact, secured in place if they're equipped on the door or the frame. Auxiliary hardware items that interfere or prohibit operation of the door are not installed on the door or the frame. Most commonly, we see like a door wedge or something like that. Those are not prohibited. Those are prohibited. Sorry. No field modifications to the door assembly have been performed that would void the label. So again, if there's field modifications, you need to bring that up to the listing agency that certifies the product, and then they can address those either through engineering evaluation, possibly testing, or depending on the severity, it might require removal of those components. So we'll take a look at some common field issues next, going through some photos. Starting on the left-hand side, we have a surface-mounted vertical rod device, and we have, might be a little bit hard to see, but there's a screw missing from the bottom right-hand corner of that device. So that one could be easily correctable, but again, it's a deficiency. It's a missing part from that component. Looking to the photo next to that on the right-hand side, we see an open hole in the face of a door. So again, that one is potentially correctable, but as it stands right now, it would be a deficiency per NFPA 80. Next, we have a hinge that could be, again, easily corrected. Could just be replaced with a new hinge. And then last but not least, on the far right-hand side, we have surface vertical rod exit devices, and as you can see, there's no strike in the floor. So there's nothing for those to latch into. So if the door is required to have 4-point latching, 2 points top and bottom each leaf, that bottom latch isn't going to do anything in its current state. So in order for that door to be completely secured, if it's meant to have 4-point latching, there needs to be a strike in the floor so that the latch bolt can engage into it. Here are a few more that we see. Corrosion does occur, depending on where the building is located, where the door and frame assembly are located. If there's severe corrosion, that may dictate replacement of that component or product of the door assembly. Looking at the next photo, we see delamination. This is a steel door, so the faces are starting to pull away from the channels. That type of issue could lead to a structural concern in the event of a fire. So again, that would be something that would be flagged, and in this case, we're probably looking at replacement for that door leaf. And then last but not least, we have a few open holes again. Looks like there's a couple small fastener holes in the frame soffit, and then we have a larger hole in the frame rabbet. The fastener holes could likely be addressed via NFPA 80 repair procedure. The larger hole would likely need to be addressed as a field modification and could be repaired. Switching gears to wood and wood composite doors, focusing on the photo on the far left, we can see some substantial damage to this wood door here. You can see a crack running almost entirely through the width of the door. Looks like there was an attempt to repair it, or at least repair the edge using the steel plate and screws. But taking a look at the overall door condition, you can see that the crack is pretty substantial. It does extend quite a ways through the door, so that door likely should be replaced. There's not really a way to repair that. Moving on to the next photo on the right, we see delamination of face material on a wood composite door. On these types of doors, the face material on the unexposed side of the door assembly is really key in maintaining structural stability during the fire endurance test. Kind of holds everything together, if you will. So when that starts to delaminate, it could lead to a significant issue in regard to the fire protection performance of that door assembly. Same thing could be said on the upper photo on the right, just moving our way to the right. We see a little chunk of face material missing from the bottom latch corner of a door. Again, wood composite doors, the unexposed facing materials do lend a lot of strength and support to those assemblies over the course of the fire test, and especially during the hose stream test as well. So if that door assembly with that chunk of material removed was fire tested and then impacted with the hose stream, likely there would be a through opening at some point, either during the fire test or hose stream. Going down, we can see a vision kit or part of a vision kit. In this case, we have glass that's removed from the upper portion, so we have a through opening in that assembly. So if there was a fire could easily pass from room of origin to the next room and spread throughout the building. So that could be as easy as potentially replacing that broken glass with fire-rated glass. And then we also see some fasteners that are missing as well. So those would need to be addressed too. And then last but not least, we see surface vertical rods. A lot of stuff going on here. We have missing components. And then as you can see, the rod on the right-hand side is definitely a little too short. The latch is not engaging to the strike at all. So that's not providing any sort of securement for that door leaf. Not to mention that the rod itself looks bent as well. In that case, those items would likely need to be replaced, that hardware. So some installation considerations. Going back to gaps between the door and the door frame, we consistently see assemblies having clearance issues in the field. So what is allowed per NFPA 80, maximum 3/4 inch underneath the bottom of the door. If we're looking at the door to frame interface, hollow metal doors are allowed 1/8 of an inch plus or minus 1/16 of an inch between the door and the door frame, or between the meeting edges of a pair of doors. Wood doors, it depends on the fire protection duration and door construction. These allowances were redefined in the 2016 version of NFPA 80, which carried on to the 2019 as well, to allow an additional 1/16 of an inch for 20-minute applications. All other wood door and wood composite door applications, aside from that 20-minute allowance, do require the 1/8 of an inch with no plus. And that's between the door and the door frame, as well as the meeting edge of the pair. Those measurements are taken from the pull side of the assembly. So what are the results of excessive gaps? First and foremost would be reduced latch engagement into the frame strike. This limits the ability of the latch to keep the door closed during a fire. For door and frame assemblies that require intumescent edge seals or smoke and draft gaskets, this increases the area that the intumescent or gasket material must fill in order to seal a gap. So for an intumescent application, if the intumescent material fails to completely fill the gap because the gap is too large, you could get flame penetration and the formation of through openings between the door and the door frame interface, or between the meeting edge interface, which could result in the failure of that opening to contain and prevent the spread of fire. If we look at air leakage or smoke and draft, the opening protective may allow for an excessive amount of air leakage or smoke development if that smoke and draft gasket cannot properly interface with the door and the frame. That could make it difficult for people to exit the building, cause loss of life, health issues in the event of a fire. Here's just some pictures kind of reiterating what we just talked about. So on the far left, you can see the full door assembly. There's some gaps that look like they might be in tolerance, but certainly the top latch corner and bottom latch corner appear to be well outside of the tolerance allowed. So again, you know, if that door assembly would require intumescent materials or a smoke and draft seal, likely it's not going to do its job, and there's going to be issues if there's a fire. In regard to the latch bolt throw, you can see that on the next two pictures. The middle one is very clear. You can see that that latch bolt is barely engaging into the frame strike because of the excessive gap. So if there were a fire, the ability for that door to remain closed and secure would be very doubtful. What is allowed in the field? This is in section 4.1.3 of NFPA 80. It's in the 2013, 2016, and 2019 versions. First and foremost, holes for surface applied hardware, functional holes for mortise locks, and holes for labeled viewers. These are round holes, maximum 1-inch diameter, with the exception of cylinders. Maximum 3/4 inch undercutting for wood and wood composite doors is allowed. Undercutting for other types of doors is not permitted to be done in the field. And last but not least, the installation of protection plates. In the 2016 and 2019 versions of NFPA 80, there were additional allowances for what can be done in the field. These include round holes greater than 1 inch in diameter for surface applied hardware in accordance with the door manufacturer's listing and the hardware manufacturer's listing. Drilling raceways for wires in accordance with the door manufacturer's listing and when permitted by the third-party certification agency that lists the door. We do have an Intertech Raceway Installers IQP program. IQP is short for Intertech Qualified Personnel. This allows members or participants of that program to drill raceways in the field for Intertech listed wood and wood composite doors. If you're interested in that program, we do have additional information available on our website. The 2019 version of NFPA 80 also had a provision for the preparation of fire pins in the field, again in accordance with the manufacturer's listing and when permitted by the lab that certifies the door listing agency. All other items are considered field modifications and need to be addressed by the listing agency. These could be addressed potentially by evaluation or additional testing, and then field inspection and field labeling following that. As I mentioned before, depending on the severity of the field modification, there may be instances where it's just not possible to approve. It's too far beyond what we have information to support, and that may require the door or the door frame to be removed and replaced. Some other common questions that come up. These are coming from Chapter 4 of NFPA 80. Except or restricted by individual listings, a fire door assembly is permitted to consist of labeled, listed, or classified components of different organizations that are acceptable to the AHJ. So what that means is that a door and frame assembly doesn't necessarily need to bear the same certification label or fire label from one organization. meaning that you could have the frame labeled from one organization, the door labeled from another organization, and then the hardware labeled from other organizations as well. Fire resistance rated glazing is permitted in doors and windows having a fire protection rating of 3 hours or less. If it's also tested and listed to NFPA 252 or NFPA 257 respectively, that's limited to the maximum area tested. And in addition to that, I would recommend consulting the door frame manufacturer's listing as well to ensure that that product is capable of having that material or size of glazing installed in it. Looking at Chapter 6 for swinging doors with builder's hardware, this one comes up quite a bit. Louvers are not permitted in side panels or transom panels. That's not allowed. Thresholds need to be non-combustible or listed products. Threshold is also different than a sill. Those words get mixed up from time to time. There is definitions for both in NFPA 80 if you need that. There is a table within NFPA 80 Chapter 6 for hinges. This lists the most common applications, but it doesn't list all applications. So again, consult the door and hardware manufacturer's listings for other hinge applications or allowances for side hinged swinging doors. And last but not least, latching requirements. Positive latching is required for door assemblies. However, there are exemptions within Chapter 6 of NFPA 80 for deadbolts and flush bolts on the inactive leaf of a pair. Next, we're going to take a look at fire door labeling guidelines. Prior to the 2016 version of NFPA 80, this would be 2013 and prior, there wasn't any specific label verbiage within NFPA 80 labeling requirements. So that fell back on the IBC requirements. Starting in 2016, there were specific requirements within NFPA 80 on what needs to be on a label. This includes fire door labels, fire door frame labels, the etch on glass, oversized assembly labels, as well as field labeled products. So prior to that, if we go back to the IBC, the minimum label requirements for doors and frames were that for doors, the manufacturer's name or traceable alternate had to be on the label, the name or trademark of a third-party inspection agency, such as the Warnock-Hersey mark shown to the right, the fire protection rating for the door, temperaturized rating when required, and an S if it met smoke and draft requirements. Frames only were required to have the manufacturer's name or traceable alternate, as well as the name or trademark of a third-party inspection agency. I will say that the requirements now within NFPA 80 are more defined than what was previously defined within the IBC. So I encourage you to take a look at that and make sure your labels are up to code. Next, we'll take a look at what an actual field labeling label looks like. The requirements for what needs to be on this label are defined by NFPA 80. This, again, would be the 2016 version and beyond within Chapter 5, and then the listing agency's requirements. This specific label is Mylar, but there are also metal labels that are allowed as well. So those would be the two most common substrates for fire door frame for field inspection. So applicable information here, if we look at requirements defined by NFPA 80, we have the words field inspected. In this case, it's a door label, so we have the words fire door. We have the rating on the label. We have a serial number for traceability on the label. That's the WHI-028375 number. And then we also have the test standards. So those are all requirements of NFPA 80. And then everything beyond that is a requirement that we have as a listing agency. We'll go through some additional resources that might be beneficial to you. So again, here's NFPA 80. We talked a lot about that today. A lot of good information in here, but all listed fire doors and components must be installed per NFPA 80 for the certification to be considered valid. Applicable sections, primary sections that we'd be using would be Chapter 4, General Requirements. Again, this is the allowable job site preparations, labeling guidelines. Chapter 5, we have inspection, testing, and maintenance. Field modifications and field labeling are covered under that section, as well as the 13 points of inspection we talked about previously. And then Chapter 6, dealing with swinging doors with builder's hardware. So that's where you're going to find your clearance information, builder's hardware guidelines, hinge requirements, lock requirements, things like that. Shown on the right-hand side, we have two different versions shown. We have the standard version, which is the orange cover on the bottom photo, and then we have a handbook edition that has the black cover. I do like the handbook edition because it also includes a commentary section. It goes into a little bit of interpretation and things like that. NFPA 101 is another great resource, has additional requirements for fire doors. It's the life safety code. Chapters of interest might be Chapter 7, means of egress, some latch lock configuration guidelines, closing guidelines for doors, and Chapter 8, features of fire protection. So again, we have the same fire rating chart as in the IBC with the different wall ratings and door ratings and that sort of thing. This is also a great document because it has sections for different types of occupancies, healthcare, educational facilities, etc. Online certification directories. So here are our two, Spec Direct on the left-hand side and our Intertech directory of building products on the right. Both of those are connected together, but they do provide a lot of good information for the public to at least see what companies have listed products, what those products might be, and some very general requirements that go along with those. And last but not least, if you're interested in learning more information about doors, frames, hardware in general, I strongly recommend taking some DHI courses at Door and Hardware Institute. There's some online courses that deal with the fundamentals of architectural doors and hardware, introduction to building codes if you're not really familiar with those items. And then there's some face-to-face courses as well. There is an inspection course, DAI 600, and that is for the fire and egress door assembly inspector. That's not field labeling, but it would allow someone to perform an annual NFPA 80 or 101 inspection. So some closing thoughts here. First and foremost, many disasters are preventable, and ensuring that a facility follows the requirements of NFPA 80 and 101, in addition to maintaining a regular maintenance schedule for opening protectives, will ensure building integrity and the safety of building occupants in the event of a fire. Last but not least, when choosing a field labeling agency, please keep in mind the risk and liability involved with this service and the knowledge and experience required to properly identify compliant products and non-compliant products in the field. Leave you with one last photo here. A lot of things going on in this assembly, a lot of non-compliances. But again, knowing the codes, knowing what's allowed and what's not allowed, keeping means of egress open so people can exit safely if there is a fire. That's all very, very important. So with that, I thank you for your time. Looks like we have a little bit of time left over to take on some questions. So let's see what we got here. All right, so first question coming in. I have a steel door frame in my hospital that is missing a rubber stopper. Is that an issue? Well, first and foremost, it would be a violation of the 13 inspection points because you have an open hole within that frame. So these are typically, I'm assuming what this person is referring to is the rubber stoppers that you occasionally see on the frame stop. There typically are 3 of them along the height of the latch jamb. So yes, it would be an issue because you'd have an open hole. Easiest way to fix it would be to just replace it with a new rubber stopper. may not seem like a lot, but the rubber stoppers do help properly align the latch with the strike. So it is necessary. Let's see what else we have. All right, here's one. I am working with an architect that wants to place panels on the face of a fire door to match the wall finish. Can this be handled as a field modification? It's possible that it could be handled as a field modification. We'd have to take a look at what the door allows for. So if you know the manufacturer of the door, the supplier of the door, we could then take a look at the listing requirements and see what that door is permitted to have installed on it. If it's permitted to have cladding or a panel applied or something like that. If it's not, then it would depend on the door type, the fire rating, as well as the panel type. So we would have to take a look at all of that information, see what we have on file to justify it, and if it would be possible to make an engineering judgment on that as a field modification, or if we would possibly need testing or to deny the request. Let's see. Take one more. Here's a question. Does Intertek also perform annual NFPA 80-101 fire and egress door inspections? We do. So again, that would be separate from field labeling. That's going through a facility and again, using our 13 steps as well as information provided in NFPA 101 to inspect fire and egress doors throughout a building. We do have staff that have gone through the DHI training program for that application. So again, that would be a possibility for us to perform that work as well. Looks like we're coming to the top of the hour here. Just wanted to thank everyone for their participation today. Any other questions that were submitted, we'll review those and we'll be addressing those within the coming business days. So again, thanks for the time and have a great rest of your day.